Okay. Bismillah ar-Rahman ar-Rahim. We'll continue to finish this section 9.2. We did this one. Now the next one. If the series converge, find its sum. Yeah, very clear. This is telescopic. So this one will be summation n equal 1 to infinity. I have a over n plus b over n plus 2. Yeah. What is a? If I cover n, a will be 2. Yeah. Substitute n be 0, 4 over 2, which is 0, which is 2. I mean, I cover this n plus 2. Then I have n minus. I have minus 2. I have minus 2. Partial fraction. I mean, do it the way you like. I can take 2 common factor. I have summation n equal 1 to infinity. 1 over n minus 1 over n plus 2. Okay. Then I'll do my calculation with this one. Then I multiply by 2. Or you can leave it with 2. It's up to you. So you have Sn will be A1. This is starting with n. This is easy. Actually, at the end, everything goes to infinity, so I have no problem. But this is will go exactly this. So I have what? Yeah, be careful here. I have 1 over 1 minus 1 over 3. So it seems I have 2 terms. A2, I have half, no cancellation, minus 1 over 4. Yeah, so I need 1 term, 1 over 3, minus 1 over 5. Now the cancellation will start. So I need 2 terms. I have plus 1 over 4, minus 1 over 6. So this is cancelled with this. Plus, so also I need 2 terms at the end. So I need an minus 1 also. So I have 1 over n minus 1, minus 1 over n. Yeah. 1 over n plus 1. Yeah, n minus 1, I put it here. So I have 1 over n plus the last 1 over n over minus n over 2. So these cancelled, and this also cancelled somehow here. Okay, so the remaining terms, I have Sn. I have 2 terms from each side, 1 minus half. Okay. Yeah. I have 1 minus half. Is it? And 0, I have 2 outside. Oh, 1 plus half. Sorry. This is 1 plus half. This plus or minus now. Minus 1 over n plus 1, minus 1 over n plus 2. Yeah. So it will be S. With the limit as n goes to infinity of Sn. That will be what? 3 over 2 here. And there I have 0, 0. Yeah. Minus 0, minus 0. So I have 3 over 2. Don't forget, this is the sum of this one. So the sum of this expression will be 2 times 3 over 2, which is 3. Sorry, this is plus. So this is the answer. This one to the power 3n, then n over 5 to the power n. Yeah, this one will be summation n equal to 1 to infinity of what? 8 2 to the power 3, 8 to the power n, ln n over 5 to the power n. In other words, is summation n equal 1 to infinity 8 over 5 to the power n times ln n. Okay. So the n term is this one. And notice what will be the limit of n as n goes to infinity. This number is greater than 1. So any number to the power infinity, greater than that will be infinity, then infinity, infinity, so that will be infinity. So the sequence, or the series, the series will do what? Diverges. Yeah. If the limit is not equal to 0, then the series diverge. This one. Sine n pi. What is sine n pi? Notice sine n pi. Sine n pi. Now, if n equal 1, sine n pi is what? Sine pi, which is 0. If n equal 2, it will be sine 2 pi, which is 0. If n equal to 3, that will be sine 3 pi. So very clear for me, sine n pi equal to 0 for n 1, 2, 3, etc. Okay. So this series actually it is summation n equal 1 to infinity 0 plus 2 to the power 3, which is 8 to the power n over 9 to the power n. In other words, it's 8 over 9 to the power n. That's it. Oh, and this one I can rewrite it to be in the format. I can take one outside. So I have 8 over 9 outside. So that will be my A, and that will be my R. R is 8 over 9, which is absolute value less than 1. So it will be S converges, and S will be 8 over 9 over 1 minus R minus 8 over 9. It will be 8 over 9 over 9 over 9 minus 8 over 9, 1 over 9. That will be 8. This is the answer. Yeah, this one. And let me do the calculation. N equal 1 to infinity. Yeah, I have minus 1 to the power n minus 1. 3 to the power n minus 1. Here I have what? 5 square times 5 to the power n minus 1. Yeah, because I need it to be the same power. So I make this n minus 1 times 2. Yeah, n minus 1 plus 2, I mean, as a product 5 squared times 5 to the power n minus 1. So this one I can rewrite it, summation n equal 1 to infinity 1 over 25, which is 5 squared, minus 3 over 5 all to the power n minus 1. So now it's very clear. This is my A, and this is my R. So absolute value of R will be less than 1, so converges. So it will be S, it will be A over 1 minus R. Be careful with the calculation. 1 over 25 over 1 minus 3 over 5, so it will be plus 3 over 5. And that give me what? 1 over 25 over 5 plus 3, 8 over 5. So that will be 1 over 25 times 5 over 8. Okay. That will be 1, that will be 5. So you have 1 over 40. You have everything in decimal. So I can multiply by what? Yeah, to make it by 25. Yeah, 25 or 25. What is 40 times 25? That will be, yeah, this is 0. 4 times this is 100, 1000. Yeah, so I have 25 over 1000, which is 0.025. And this is the answer. Yeah, just represent it as decimals. Okay. What is this? 1/3 times 4 plus 1/4 times 5. Yeah, I need to rewrite it as a series. That will be this one, 3, 4, 5, 6. So you have 1 over, let me start from 3 to infinity. So this will be n, huh? N, 3, then 4, then 5. And the other one will be n plus 1. Yeah, that will be the form it as a series. Okay, so this one now I'll do my calculation for this one. So I need partial fraction, where I have what? A over n plus b over n plus 1. What will be A? Cover this. A will be minus 1, huh? And B would cover this in minus 1. I put minus 1, so I have minus 1 here. So it's summation n equals 3 to infinity, 1 over n minus 1 over n plus 1. Yeah. So actually I will do sk like if I'm starting from 3, huh? Up to, I don't know, I don't care, make it ak or anything. Just because I need the sum. So there will be cancellation. So I'm doing it this way. So I have A3 will be what? 1 over 3 minus 1 over 4. A4 will be 1 over 4 minus 1 over 5. So cancellation very clear. I need only one term. One term. So I have what? 1 over k minus 1 over k plus 1. And this will be cancelled. So my sk will be 1 over 3 minus something like this. With another maybe expression, but it will be okay. So it will be S, since I'm doing the limit k goes to infinity of this, that will go to 0. So you have 1 over 3. So the sum is, conversion, the sum is 1 over 3. 2n over n plus 1. Yeah, it is very clear. an is 2n over n plus 1. What will be the limit of an as n goes to infinity? Limit n goes to infinity to n over n plus 1, same degree. So it will be just the coefficient 2, not equal to 0. So the series diverges. Yeah. Let A and be a sequence of real numbers. He gave you what? He gave you Sn. I think we did that before. No, just something similar. Sn. He gave you Sn. By the way, he doesn't want An. He wants An over 2. He wants An over 2. So let me call it Bn. So my Bn is An over 2, which is what? Now, this is my Bn. Huh? So it will be Sn for this one. Sn for the B's. B1 plus B2 plus Bn. That give me A1 over 2 plus A2 over 2 plus An over 2. I can take half outside. I have A1 plus A2 plus An. That will be half. And I know this is this one. Half times this expression, n square over 3n square plus 7. In other words, it will be n square over 6n square plus 14. So it will be S, will be the limit of Sn as n goes to infinity. Yeah, and that limit is very clear. Will be same degree, huh? So it will be 1 over 6. And that will be the answer. Yeah. Series n tan 1 over n. So check this is the n term. What will be the limit of an as n goes to infinity? It will be the limit as n goes to infinity of n tan 1 over n. Yeah, if you let t equal 1 over n, what you will get? That will be limit t goes to 0 n is 1 over t, and that will be tan t, which we know it, which is similar to sine t over t, and that will be 1, not equal to 0. So the series diverges. The power n minus 1 minus e to the power n. Yeah, you need to manipulate it a little bit. It's just the power things. So you have e to the power n times e's minus 1 minus e to the power n over e to the power 2n times e to the power minus 1. So I split it into two series. I have e to the power n. Let me do it in details. Minus summation e to the power n over e to the power 2n times e's minus 1. Yeah, these cancelled. So I have what? Summation n equal 1 to infinity. 1 over e to the power n here. And this one, I have what? This is e times 1 over e to the power n. Yeah. So I need to call this one, call this 2. So for 1, what will be a? At n equal 1, it will be 1 over e. Yeah. And r is 1 over e. So it will be s for 1. It will be 1 over a over 1 minus 1 over a. And that is what? 1 over a over a minus 1 over a. That will be 1 over a minus 1. So this one is 1 over a minus 1. Now for 2, what is a? A is at n equal 1. It will be 1. And what is r? 1 over a. So it will be s 1 over 1 minus 1 over a. And that will be what? E over 1 minus e. So that will be minus e over 1 minus e here. Is it? No, e minus 1, sorry. Let me do it in details. It will be 1 over e minus 1 over e. And that will be e over e minus 1. So that will be e minus 1. That will be 1 minus e over e minus 1, which is minus e minus 1 over e minus 1 cancelled. I'm getting minus 1. So this is the answer. Sum minus 1. Okay. What will happen to this one? He gave you Sn. So what will be S will be the limit as n goes to infinity of Sn. And that will be the limit as n goes to infinity, e to the power n over n. We substitute to get what? Infinity over infinity. So I need L'Hopital's rule. That will be limit n goes to infinity, e to the power n over 1. And that will be infinity. So the series will do what? Diverges. I think we have only, yeah, okay. Let me do them quickly. I have an is the nth root of 10, which 10 to the power 1 over n. What will be the limit of an as n goes to infinity? Yeah, it will be very clear. This is 10 to the power 1 over n. As n goes to infinity, this will be 0. So it will be 10 to the power 0, which is 1, not equal to 0. So the series diverges. Okay. Sine 3 over 2 to the power n over cosine over cosecant square 3. Okay. Let me try to manipulate it. That will be summation n equals 0 to infinity. Sine square 3 all to the power n. And let me do it this way. That will be 1 over cosecant square 3 times sine 3 sine square 3 to the power n. Yeah. So now A will be at n equals 0. So that will be 1 over the first term, cosecant cubed. And what is r? R is sine square 3. Geometric, very clear, this is geometric. Huh? Okay, sine cube 3. Yeah, I know sine always be, that will be than 1. Very clear. Sine square 3, for sure it will be less than 1. It will not go to 1 or minus 1, so for sure it will be less than 1. A value less than 1. What is the value? I don't care. So what will be my S? It will be A over 1 minus R. And that 1 over cosecant square, that will be sine square 3 over 1 minus sine square 3. That will be what? Sine square 3 over cosine square 3. And that is tan square 3. And that will be my answer. Yeah. Find the value of B for which this is equal to 9. So we put a B somewhere. He wants me to get that B. That's what I have. I have summation. This one is summation n equals 0 to infinity. E to the power B, all to the power n. So what is A? Actually, from K, A equal 1. And R is what? E to the power B. E to the power B. This is my R. Okay. So for sure, R should be less than 1. And the most important, S. What that will give me? No, I will leave it. Just I will do it. I will do the S1. A over 1 minus R. And that equal 1 over 1 minus e to the power B. And that should equal to 9. Do the calculation. I'm looking for B. Huh? That will be 1 equal 9 minus 9 e to the power B. So I have minus 8 equal minus 9 e to the power B. That implies 8 over 9 equal e to the power B. So B will be ln 8 over 9, which I know is less than 1. This is less than 1. Yeah, because ln 1 is 0. Actually, it's yeah. Yeah. Then what is e to the power B? No, not this one. I'm talking about e to the power B. E to the power B. I want to be sure it's less than 1. It will be e to the power ln 8 over 9, which is 8 over 9, which is less than 1. So this is correct. And if B equal to this, then this is correct. This converge, and the sum is equal to 9. So ln 8 over 9. Okay. Yeah, this will be the last one. Little bit confusing. It's not a direct one. Let us see what will happen. By the way, this is a question from the book. But this is in section 9.3, but we can't do it as telescoping. That will be summation n equal to infinity ln n square minus 1 over n square. That will be summation n equal to infinity ln, what is n square minus 1? N minus 1, n plus 1 over n square. Yeah, that will give me summation n equal to infinity ln n minus 1. You know, let me do it in the next step, next line. N equal to infinity. Yeah, ln n minus 1 plus ln n plus 1 minus ln n square. And that will be summation n equal to ln n minus 1 plus ln n plus 1 minus 2 ln n. And that will be my expression. So we'll deal with this k. I'm starting with 2 plus ak. Okay. Yeah. Now I will open it. Yeah, see what will happen. It's a little bit confusing. Let me do it in the next step. That will be what? A2 will be what? Len 1 plus len 3 minus 2 len 2. That is A2. A3, be careful, huh? A3 len 2 minus plus len 4 minus 2 len 3. I need to open more, huh, to see it. Plus A4, say len 3 plus len 5 minus 2 len 4 plus, let me do more. At n equal A5, it will be len 4 plus len 6 minus 2 len 5. Let me do one more. Len 6, len 5, huh? At n equals 6. That will be len 5 plus len 7 minus 2 len 6 plus. Also, at the end, I will take 3 terms, huh? Because very clear to me what will happen. Notice this. This. Yeah, let me use a different color so that you can see it, because it's a little bit confusing. This with this cancelled. Okay. And the same thing with the len 4. And that will what will happen. So the cancellation, this will cancel this and cancel this. So I need 3 terms to see it. And the same thing, len 5, this, cancel this, cancel this. And the same thing, len 6, this, it will be cancelled somewhere here. And then 7 will be cancelled. So everything will be cancelled. Let me do the 3 terms at the end. Plus what? So I take n minus 2, let me k minus 2, k minus 1, and k, huh? The last 3. That will be what? Len, be careful. Len k minus 2. I have k minus 3 plus len with n plus 1, k minus 2 plus 1. That will be k minus 1 minus 2 len k plus at k minus 1, that will be len k minus 2 plus len k minus 2 len k minus 1 plus that will be what? Yeah, that will be the last term. Ln minus 1 plus len n plus 1 minus 2 len n. So it's the remaining. Yeah, here's the catch. Yeah. In the beginning, I have 3 terms. 1, 2, 3. So I have what? Len 1 minus len 2. The rest will be cancelled. At the end, be careful, huh? At the end, what we will have? We will have this k minus 3. It's very clear it will be cancelled somewhere before. Because it will be like this, like len 3, which will be cancelled backward, before the one before it. Okay. Now, what will be the remaining? Yeah. N minus k minus 1. The same thing with k minus 2. Then k minus 2 will be cancelled by something before. Okay. And k minus 1, very clear. This is cancelled with, oh, sorry, this is k, huh? I should use the same, yeah. K minus 1. With k minus 1, with minus 2, link k minus 1. 3 terms should stay. Sorry, this is minus 2 link k. It should not be k. This should be k minus 2. This is k minus 2. So k minus 2 will be cancelled with this, will cancel by the one before, huh? Yeah. So the remaining terms are these 3 terms. This. And it is plus ln k plus 1, ln k minus 2 ln k minus ln. Yeah. So I have what? Ln 1 is 0. So I have minus ln 2 plus ln k plus 1 over k. That's my Sn. But Sk. So it will be S, let me write it here, will be the limit as k goes to infinity of this, of Sn. And that will be limit k goes to infinity. It's just a value, so it will be minus ln 2 minus ln 2 plus ln k plus, oops. Yeah, that was not the right place because it will make it okay. I need a space. Let me try to squeeze it here. So S will be limit Sn Sk. Sk goes to infinity, which is what? This is the number. Will not be affected by the limit plus limit k goes to infinity ln k plus 1 over k. That will be minus ln 2. I can take the limit inside. That will be ln limit k goes to infinity k plus 1 over k. What is this limit? This is 1. Ln 1 will be 0. So the answer, oops. The answer is, yeah, this will be gone. This is 0. So I have minus ln 2, and this will be my answer. Yeah, I think this is the end of this section 9.2. And then I will try to do 9.3 inshallah in the next videos. I will stop the recording. Thank you.